dividing by a monomial. We use a process of what we call synthetic division. Synthetic division. So here are the steps. We're going to set the binomial equal to 0 and solve for the variable. And that number is going to go on what we call the shelf. You'll see what I'm talking about here in a second. Then we're going to list the coefficients of the polynomial beside the shelf. Make sure it's in standard form. Okay, that's very important. Make sure it's in standard form and not missing any terms. I've got an example here in a second to show you what to do if it is. Okay, so you have to make sure it's in standard form and it's not missing any terms. And then this isn't part of the process, but this is part of what this will tell us. If the remainder is 0, then the binomial is a factor, and the number on the shelf is a root, or an x-intercept, or a solution. Remember those terms, the 0, those terms that I told you got to know mean the same thing. Okay, that's what it means if the remainder is 0. So let's look at an example. Okay, number 1 here, we take the binomial v minus 3 and we set it equal to 0 and we solve for v. So in this case, that means we add 3. So v equals 3. 3 goes on this shelf. It's like a backwards L. All right, now we need to check and see if our polynomial is in standard form. Standard form means that the highest exponent comes first. So we've got v cubed, v squared, v, and a constant. Okay, that's the order it's supposed to be in. Nothing's missing. We've got an exponent of 3, 2, 1, and no exponent. So it's in the order it should be in. So we're going to list their coefficients beside the shelf. So the first coefficient is a 1. There's nothing there. It's understood to be a 1. Negative 13, 29, and 9. Bless you. Then we leave ourselves a space, like a whole line of space, because we're going to put another row of numbers there in a second, and draw a line. Okay, so here's what happens next. That first coefficient, that 1, we're going to bring it directly below the line. We don't do anything to it, we just bring it down. Then we're going to multiply that by the number on the shelf. So 1 times 3 is 3. That goes in the next spot, the next open spot there. Then we add. Negative 13 plus 3 is negative 10. And then we repeat the process. Okay? We multiply the negative 10 by the 3 on the shelf, and we get negative 30. Then we add. 29 plus negative 30 is negative 1. Then we multiply by the number on the shelf. Negative 1 times 3 is negative 3. Then we add. We get 6. That last number right there is our remainder. Okay, the last number is always the remainder. Now, we just have a list of numbers. What does that mean? Well, we started with v cubed, so then we reduce the degree by 1. So that's going to be v squared and v. So here's our answer. Here's how we write it. We write it v squared minus 10v minus 1, because the 10 and the 1 were negatives, plus our remainder over what we divided by. Okay, it's just like go way back to elementary school, because y'all are so old. Go way back to elementary school when you did long division and you got to the end and you had a remainder. What did you put the remainder over? The number you divided by. So we do the same thing here. We put the remainder over what we divided by, but it's not just a number. We got to put it over the expression that we actually divided by. Okay? So that's our answer there in red. Okay. I know that's completely new, so let's do another example. Okay. This time we're dividing by n minus 7. So what number is going to go on the shelf? Positive 7. Okay, n minus 7 equal to 0. Solve for n. I know these are simple ones to solve, but we'll do some here in a minute where there's a second step to the solving. So that's why I'd still do it. All right. Are we in standard form with the polynomial? Yes, we are. N cubed, n squared, n constant. And we're in order, so we can just list those coefficients. 1, -6, -17, and 70. Leave the space, draw the line. Okay, bring down the 1, multiply by the 7 on the shelf. We get 7. Then we add. -6 plus 7 is 1. Multiply by the number on the shelf. We get 7. Add. -17 plus 7 is -10. Multiply by the number on the shelf. -7. Add. We get 0. Okay, so this is different from the problem that we had before. We don't have a remainder. Okay, so in regular old long division, when you don't have a remainder, that means they divided evenly, right? So that means that n squared plus n minus 10 is our answer. That means if we graphed n cubed minus 6n squared minus 17n plus 70, guess what one of the x-intercepts would be? 7. Okay, let me show you that. I want you to see this on the graph as well. So if I plug in x cubed minus 6x squared minus 17x plus 70, and I graph it, okay, there's one x-intercept over there, there's one x-intercept. Look at this one right here. It hits it right on the head at 7. Okay, so I don't know about those other two right now, but I do know I did expect it to cross there at positive 7 because when I divided, I got a remainder of 0. So that means whatever number's on the shelf is an x-intercept, it's a solution, it's a 0, it's a root, whatever you want to call it, that works out. Okay, and then we're left with this quadratic over here. To find the other x-intercepts, we would like to be able to factor. We can't factor, so our next option is to use the quadratic formula to find the exact answers. Okay, we could use the calculator here and find those zeros and get the decimal values, but if we wanted the exact answers, we'd have to use the quadratic formula on n squared plus n minus 10. Okay, all right. Let's do a couple more just to make sure that we're all on the same page here. Okay, 5 is going to go on the shelf on this one, r minus 5. So 5 goes on the shelf. That leading coefficient's not positive 1 this time, it's -1. Notice, because it's negative r squared, or excuse me, negative r to the 4th. Then our r cubed is 14, our r squared is -36, our r is missing. So what do you think we should put there if something's missing? 0. Perfect. Okay, we put a 0 there if something's missing. We don't put a 1, because that's what we put if it just doesn't have a coefficient. Okay, if it's missing, the r is missing right here, we put a 0 in its place. All right, so let's do our division. It doesn't change our division. Okay, we just had to make sure we did that in the beginning. Yes, sir.
It has 49.
There's a 49. Oh, I think I took it out to make sure that I had one that was missing one. So yeah, mark that out. Sorry. Yeah, mark out the 49R. I took that out to make sure that we had one that was missing a term. Sorry. Thank you for mentioning that. Just mark out the 49R. Okay, bring down the -1, multiply by the 5 on the shelf. We get -5. So then we add, 14 plus -5 is 9. Multiply by the 5 on the shelf, we get 45. Negative 36 plus 45 is 9 again. Multiply by the 5 on the shelf, we have 45. Add, we have 45. 45 times 5, got to cheat and use my calculator, 225. And then we add, we get what, 244? Okay, normally the remainders are not that ginormous, okay, but it happened in this case because I changed the problem to make it work where I had an example like this, okay? So here's our answer. Negative r cubed plus 9r squared plus 9r plus 45 plus 244 over what? R minus 5. Okay? Do we feel comfortable with it, or do we want to do a couple more examples just to make sure? Y'all tell me. Are we good to practice, or you need to see another one? Let's do another one just to make sure. Okay? I had a couple more examples prepared, so let's use them. Okay, number 4, x to the 5th. They keep getting bigger. X to the 5th plus x to the 4th minus 26x cubed minus 36x squared minus 28x plus 10. Woo! All right, this time we put a negative number on the shelf. We haven't had to deal with that so far. X plus 5 means negative 5 is going to go on the shelf. So we've got 1, negative 26, negative 36, negative 28, and positive 10. Okay, we can do these problems as big as we need to do them or as small as they need to be done. The process still works. Okay, bring down the first coefficient. 1 times negative 5, negative 5. Add 1 plus negative 5, negative 4. Multiply negative 4 times negative 5, positive 20. Add negative 26 plus 20 is negative 6. Multiply negative 6 times negative 5, positive 30. Add negative 36 plus 30, negative 6. Multiply negative 6 times negative 5, 30. Add negative 28 plus 32. Multiply negative 10. Add, we get 0. So we've got another one that was evenly divisible. We started with x to the 5th, so we reduced that degree by 1. So we've got x to the 4th minus 4x cubed minus 6x squared minus 6x plus 2. All right, last one, and then I'm going to let y'all practice for a minute or a few minutes. Okay, number 5, what goes on the shelf? Negative 9. Okay, so a to the 5th has a coefficient of 7. A to the 4th has a coefficient of 63. A cubed is missing. Okay, if you don't put that 0 in its place, it will mess up everything after that step. So a squared is negative 10, a is negative 87, and the constant is 36. So bring down the 7. We've only ever brought down 1 and negative 1, but we can bring down whatever numbers first. Bring down the 7, multiply. 7 times negative 9 is negative 63. Add, we get 0. 0 times negative 9 is 0. Add, we get 0. Multiply, we get 0. Add, finally don't get 0. Negative 10 plus 0 is negative 10. Multiply, negative 10 times negative 9 is positive 90. You got to be careful with these negatives. Okay, negative 87 plus 90 is 3, positive 3. 3 times negative 9 is negative 27. And 36 plus negative 27 is 9. So, we have a remainder of 9. We started with a to the 5th, so we've got a to the 4th, a cubed, a squared, a. That's why I like to put them right there, because really we don't need all those zeros in our answer. We really only need the 7a to the 4th minus 10a plus 3 plus 9 over a plus 9. And no, you cannot cancel those 9s. Okay? So if you've got zeros in your answer, you can just leave that part out, but I kind of needed them up here to know that I need to skip the a cubed and skip the a squared. Okay? All right, so pretty straightforward process. You just got to be careful with it.